Hello, you are welcome once again to new focused approach to mathematics basic 8. This is the revised edition, and in this video we want to look at the relationship between the basic trigonometric ratios. Now we want to look at the relationship that exists between basic trig ratios, more especially when we are dealing with right angle triangle. And so with right angle triangle, we have basic ratios as sine, the complement of sine, that is the cosine, and then the tangent. So in a short form, we say sine of an angle, cos of an angle, and tan of an angle. We want to look at the relationship between these trig ratios. Now, we will start with the concept of right-angled triangle. Anytime we have a triangle and one of the interior angles happen to be 90 degrees like this one, then we call this type of triangle right-angled triangle. And when we have right-angled triangle, always the opposite side of this right angle is this line we call the hypotenuse. Okay. And then once we make a reference of an angle, theta here, then the side opposite this theta, we call it the opposite side. And then adjacent to this side, we call it the adjacent side. Okay. When the right angle happens to be like this, we still have opposite to the right angle, that's the 90 degrees, the longest side being called the hypotenuse. And because the angle is here, its opposite becomes this. So here becomes the opposite side. And then this side becomes the adjacent side. Okay. Right. So that is right angle triangle. Now let's see how we can relate the size and then the angles. In fact, all we are trying to do here is to see the relationship between this angle theta and the size of the triangle in reference to the three fundamental ratios, the cos, the sine, and then the tan. Right. So now what I want you to do first is to get yourself a graph book and then draw two perpendicular lines. Label it y-axis and then x-axis. Okay. And then maybe do your demarcations by maybe keeping 1 centimeter to 1 unit or 2 centimeters to 2 units. As we have here, I've demarcated this and I've demarcated that as well. Now, what I want you to do is use your protractor and from the x-axis, measure a particular angle. It can be, what I have here is 26.57. You can make it 30 degrees, 45 degrees, 42 degrees, any angle at all, but it must be acute angle. Then draw a straight line like this one. Draw a straight line like this one. When you finish, try to pick any point, just point at all on the line. Pick any point at all on the line, like point C here, D here, G here. And draw a perpendicular line to meet the x-axis, making sure that the line meets the x-axis at an angle of 90 degrees, exactly 90 degrees. That's why I want you to use graph book for this, so that you can get it accurate. Right. Now, what I want you to do next is to measure, consider the triangle A, D, and C, measure the distance AD and measure the distance AC. The same thing, draw another line and measure the distance AF and distance AE. The same thing, measure the distance AJ together and measure the distance AH. In each of the triangle, make reference to the A, okay, and then either to the AC and D as one triangle, or AE and F as another triangle, or AJ and H. Whichever way you go, you get what I'm going to let you do. Now, let's consider a triangle A, D, and then C. Okay. Now, with A, D, and C, the dimension for DC is 2. Now, if I pick DC, okay, and I take the ratio of DC to any of the sides, let's say AC, okay, AC, then this should be the same as if I make reference of AF is to AE. The ratio of this should be the same as the ratio of that, if all your dimensions are accurate as I have here. The same thing can also happen to AH, okay, and that of JH as well. You get the same answer. Now, I want you to pick a calculator. This one, I would like you to use calculator for this. Now, what is our DC? DC is 2 according to my dimension here. If ratio means division, so DC 2 divided by AC, and the AC is 4.47. I should expect this 2 over 4.47 should be the same as EF. EF. This one should be EF rather, not AF. EF. And EF EF, okay, that's EF, this one, which is 3, also divided by AE, and AE is going to be addition of 4.47 and that of the 2.24. So when we add, we'll get 6.171. Okay, now with the help of your calculator, do 2 divided by 4.47. Let's see the result. 2 divided by 4.47, the result is 0.4474. The same thing when you divide 3 also divided by 6.71, you get the same results. When you can pause the video and try it for this one. Try it for that of the HJ, which is 5, also divided by A to J, and A to J will be 11.18. When you divide 5 over 11.18, you get the same as the answer we have as 0.4474, and so on and so forth. Now, again, what I want you to do is this. Pick the sign, or let's say pick calculator again, and on your calculator, type sine or key in sine the angle here, this angle, which is 626.57. You realize that the result of this will be the same as this one as well. What does that mean? What it means is that if I pick the sine of the angle, which is 26.57, it should be equal to the opposite side here, which is 2, divided by the hypotenuse side here, which is 4.47. Now, if I choose not to use the opposite side here, but I choose the adjacent side and divide it by the hypotenuse side, I will get the answer to be cos of the angle 26.57. If I don't do the hypotenuse and adjacent and I do opposite side and that of the adjacent side, I will get tan of the angle 26.57. If you do your angle here as 30, then it will work for 30. If you make the angle here 50, it will work for 50. This experiment, try it on your own and you will see the amazing aspect of mathematics. So in conclusion, what we are trying to learn here is that anytime you have right angle triangle, okay, and you pick the sine ratio, that's the sine of the angle given is always equal to the opposite side of the angle divided by the hypotenuse side, which is A over C. To remember this, we use the acronym SOH. That is, with the sine, we say opposite over hypotenuse. The same thing if you take the other ratio like the cos or the complement of sine, and you pick the sine of this angle, it will always be equal to picking the adjacent side, the B, and dividing it by the hypotenuse side. And to remember the cos, we'll use the word CAH. The same thing when we pick that of the tan theta or tan, that means when we measure the opposite side of the angle and divide it by the adjacent side of the same angle, we will get the value of the tan of this angle that is here. To remember it, we call it TOA. That is TOA. That is tan means opposite over adjacent. And so we use this acronym SOH CAH TOA to remember this concept. So anytime you hear SOH CAH TOA, it helps you to know the relationship between angles and the size of the angle in relation to the trig ratio. Again, if you say SOH, it means opposite over hypotenuse. If you say CAH, cos, adjacent over hypotenuse. If you say TOA, tan, opposite over adjacent. I'm sure this illustration has helped you to understand the concept of trig ratios. In our next video, we are going to take questions and see how we can apply this concept in solving questions. Thanks so much for watching.